Hello everyone, I am Iot from third year Computer Science Engineering. In this video, I am presenting my project internship on IoT. Presentation is about IoT based home automation system. So let's take a look at table of contents. First, I will give you information about internship. Then
I will come to explain about the project and then uh, how I implemented the project and the conclusion. Okay, let me take some information about the internship. It was from Emertxe Information Technology, Bangalore. The duration was about 4 weeks, and this internship was well organized, finely structured, and one kind of standard internship. And this internship was like a PBL based or project based learning and learning with implementation. And in this internship, students support Students are supported through the Moodle LMS learning management system, and also in this internship, the students were provided free resources and tools. In that internship, we were having the project about home automation, and also there are weekly evolution of the student. Let's cover some topics which I learned in this internship. Here, I divided these topics like learning part and project part. Learning parts which required to build the project. So in this topics, I'll first learn C and C++ programming, then object-oriented programming concept, IoT introduction, embedded system introduction, and workshop. But in project part, mainly I learned the peripherals, uh, Arduino programming, Lab simulation, how to handle the Blink IoT app, and the project. Then what is IoT? IoT, the Internet of Things. Internet means what internet? Internet means network, and things means day-to-day object. The combination of object with the help of network or the help of internet. IoT is a network of physical object, collection of electronics, software, sensors, and network connectivity, which collect and exchange the data, or we can handle the data, or we can analyze the data. Ecosystem of IoT. IoT ecosystem is based on layers, 7 layers of IoT ecosystem. First is IoT devices, then it is network or the internet, then the security and privacy and the gateway and the data cloud, that's data storage, and we need one kind of user interface, that is application, and then most required is users. We need users to handle these IoT devices. Then moving towards what is embedded system. An embedded system is the combination of computer hardware and software designed for the specific function. An embedded system is a computer system which is the combination of the processor, memory, input-output peripheral devices, and many more. Memory is such an essential part of embedded system. And also there are power management system and data handling systems. Then uh, you also have a question, what is the difference between embedded system and IoT? The difference between an embedded system and IoT is an embedded system is a subset of IoT. IoT is a broad and embedded system is one of the subset of IoT. The types of IoT. There are mainly 4 types of embedded system: real-time embedded system, standalone embedded system, network embedded system, mobile embedded system. Real-time embedded system are strictly followed by the time, or their output should be in time. So that's why their examples are like self-driving vehicle control, aircraft control system, medical devices, and patient monitoring system, which are time bounded. We need output in strict time period. And then standalone embedded system, like embedded system which don't require that much time, and also don't sometimes don't require the operating system to perform. That is, examples are digital cameras, music players, washing machines. And then network embedded system, which like internetly connected embedded system, like home security system, ATMs, and point of sale system, that is we see in day-to-day manufacturers or the stores are putting their system that scan the QR code. That is the point of sale system. And the mobile embedded system, like we mobile at everywhere, that is cell phones, laptop, or smartwatches. Here are some of the examples of embedded system. As you see, the GPS system in cars, digital watches, airports, and medical, and then cameras. There are camera is the standalone. There are and mobile. There are lots of example of embedded system. Then moving towards the learning part of programming that I learned in this internship, C and C++ programming. I divided this in three parts, just in weeks wise. That at starting I learned basics of C, and then intermediate of C, and advanced in CPP, that is C++. Variables, that is, we give the name to the something that we handle in this whole program. Keywords. There are mainly 32 keywords in C programming. But there is a note that we can't use variable name as same as of keywords. Data type. Data type, there are mainly uh, data types like integer, float, double, and the character and the string. Operators are like double than equal to, double equal to, not equal to, boolean operator, bitwise operators, and then conditions are like if else statements, case statements, switch statements, and the loopings for loop, while loop, and do while loop. In intermediate, we are learn the arrays, pointers, function, storage classes, files, preprocessor. Arrays are the same type of entities or same data types, entities which have the same data types. The pointers which point the addresses of variables and the data. The functions are the small programs which we use in our program so that we get our program run in sophisticated way. The storage classes, files, preprocessor. Preprocessor mainly the directives, that is .c or .h. That .c is the C file, and .h is header file, and also we know that .exe, that is executable file. Then moving towards advanced part, C++ overviews, and then I learned classes, and object. Class are the instances of object, and here we briefly understand the four pillars of OOP, that is object-oriented programming, are abstraction, inheritance, encapsulation, and polymorphism. About the project, home automation. There are some requirements regarding that project, making the project. Requirements are guarding light control, temperature control, heater control, threshold temperature control, water tank control, inlet and outlet wall control, display the water volume, displaying the progress and notification on the blink or the mobile app, and also on the CLCD which are using in our project with automatic actions. So here is a block diagram of our project that implemented in this project. That is, but main components are, we are using main components as Arduino Uno, Pixim Lab for the simulation, and Blink app for virtual handling. About the project, here are the peripherals of the connection we made in our project. That is, Arduino is connected with the CLCD, temperature system, Ethernet shield, and the LDR, and the LED, and Blink Cloud connections, and here the serial tank. We are connected with serial communication RX and TX. Here the RX pin is connected to the TX pin of Arduino, and TX pin is connected to the RX pin of the Arduino. About the project in, we are moving that Arduino. Arduino Uno is based on an Atmega 328P microcontroller. It is easy to use compared to other boards such as Arduino Mega board, etc. Board consists of digital and analog input-output pins and the shields and other circuit. The Arduino Uno includes 6 analog pins, inputs, 16 digital pins, and USB connector, power jack, and in-circuit serial programming. Here using the LEDs, that is light emitting diode, and temperature system, which consists of heater, cooler, and the temperature sensor ELM32. Here also we are using the liquid crystal display, that is 16 cross 2, and the remote serial tank, which show us how the tank is full, or the volume of the tank. Ethernet W5500. This chip is hardwired TCP/IP, that is a protocol, embedded Ethernet control that provide easier internet connection to the embedded system. This Ethernet enables user to have the internet connectivity in their application just by using the single chip, in which TCP IP address stack 10 to 100 Ethernet MAC and physical embedded. Supports WEC on and LAN over UDP. Supports high speed serial peripheral interface. LDR, light dependent resistors that we know. The LDR is the sequence that light is inversely proportional to resistance. As light increases, then resistance of LDR decreases. In LDR, the component that have the variable resistance that changes with the light intensity that falls upon it. This allows them to use in the light sensing circuits. The resistance of a photoresistor decreases with increasing incident light intensity. In other words, exhibit photoconductivity. About the PCF 857, the silicon CMOS circuit, it provides a general purpose remote input-output expansion for the most microcontroller families via the two-line, that is bidirectional bus. And here are how I implemented the project. We are moving towards the project implementation. Hello, here can see you the project code that I built in this internship. Here are the files with LDR CPP, LDR header files. That is a preprocessor as we seen in the learnings. Then we are moving towards the implementation. As I fill the hex file on this, and then I get the interface about the home automation on a blink, and then I can handle this remotely, as you can see. Here you can see if I click on the cooler button, then the cooler in the temperature system starts, and here we can see also the serial tank, that is a tank which shows us the value of water. Here I off the cooler button and start the heater button, then we can see the temperature sensor changes, and also if I start the outlet valve, then water will be consumed out, and as as the water level comes down to the 200 liters, then automatically invert valve will be on and just start filling the tank. So I will off the outlet valve to fill the tank, and as you can see, here are we getting the notification about everything. The temperature is about 35 Celsius, so it automatically turn off the heater button, and as you can see the inflow dis disabled. As we can see the tank is full, so automatically the tank inlet valve will be off, and this is how can we save the water. Now moving to the last part of this, as we can see the conclusion. Using Blink IoT application and the Pixing Lab simulator, the simulated home automation where LED, temperature system, serial tank, heater, cooler, and water tank in real time. We can handle this thing in real time on using this apps, the Blink IoT app. And CLCD acts like a dashboard used for the displaying the event widgets from Blink IoT app, like buttons, widgets, or the notification bar, or the temperature sensor, or the volume sensor, which shows us how much the value of current situation. Gauge widgets to display the temperature and volume, as you can see. So moving to the last part of this presentation, I will thank the Emertxe technology to giving me the opportunity to work on this project, and also I'm looking forward to make this project in real time. This I done only in simulation manner. Thank you.
Now we will try to understand LDR, light dependent resistor sensor. An LDR is a component that has variable resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuits. The resistance of a photoresistor decreases with increasing incident light intensity. In other hand, it exhibits photo conductivity. Okay, now let's talk about PCF 8574. The PCF 8574 is a silicon CMOS circuit. This provide, provides general purpose remote IoT expansion for most microcontroller families, like by the two-line bidirectional bus. Okay, this is called 1 to C interface. The device consists of an 8-bit quasi-bidirectional port and 12C bus interface. Okay, here you can see the image of PCF 8574. Okay, let's move to another slide. This slide describes about project implementation. Okay, now you can see this is project CJ remote tank. This is fixing lab spare parts. Here is the input. Now we will move to another slide which tells about fixing lab inputs and outputs. Here is the outcome of our project. Project is about home automation system. So conclusion of this project is using blank IoT application and PiximLab simulated home automation where LED temperature serial tank resembles light heater, cooler and water tank in real time. Okay, then CLCD acts like a dashboard used for displaying the events. Okay, widgets from Blink IoT app like button widget and used to control heater, cooler and inlet wall, outlet wall. Now gauge widgets to display the temperature. We have used these gauge widgets in our project to volume the water. So this is the conclusion of our project. So we have studied about project and we have implemented our project. So thank you guys. My name is Iot Project. I am from Engineering College Bikaner, Rajasthan. I am in third year BTech Computer Science and Engineering. So thank you. If you have any query about my project, you can ask me in comments. Thank you so much. Now we will try to understand LDR, light dependent resistor sensor. An LDR is a component that has variable resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuits. The resistance of a photoresistor decreases with increasing incident light intensity. In other hand, it exhibits photoconductivity. Okay, now let's talk about PCF 8574. The PCF 8574 is a silicon CMOS circuit. This provides general purpose remote IoT expansion for most microcontroller families, like by the two-line bidirectional bus. Okay, this is called 1 to C inter-IC. The device consists of an 8-bit quasi-bidirectional port and 12C bus interface. Okay, here you can see the image of PCF 8574. Okay, let's move to another slide. This slide describes about project implementation. Okay, now you can see this is project here remote tank. This is fixing lab spare parts. Here is the input. Now we will move to another slide which tells about fixing lab inputs and outputs. Here is the outcome of our project. Project is about home automation system. So conclusion of this project is using Blank IoT application and Pixim Lab simulated home automation where LED temperature serial tank resembles light heater, cooler and water tank in real time. Okay, then CLCD acts like a dashboard used for displaying the events. Okay, widgets from Blink IoT app like button widget and used to control heater, cooler and inlet valve, outlet valve. Now gauge widgets to display the temperature. We have used these gauge widgets in our project to volume the water. So this is the conclusion of our project. So we have studied about project and we have implemented our project. So thank you guys. My name is Iot Project. I am from Engineering College Bikaner, Rajasthan. I am in third year BTech Computer Science and Engineering. So thank you. If you have any query about my project, you can ask me in comments. Thank you so much.